Question 3. We've got a oxygen dissociation curve at 2 carbon dioxide concentrations. So you've seen this before. And low is the solid line, and high CO2 is the dotted line. And here's an alveolus. We've got blood moving. It doesn't tell us which way, but we've got low oxygen there, we've got high oxygen there, and the other way around we've got high CO2 there, 5.9, and low CO2 there. So you would imagine in the lungs we're sending deoxygenated blood, so low oxygen blood. It's getting oxygen from there and then exiting. So we think the blood flow is probably going that way. Right, which of the 4 regions represents the point at which the blood in region X is in contact with the alveolus? So we have got blood that has got low CO2, 5.1 as opposed to 5.9, so that's putting us on the solid line. And A, B, C or D, so we definitely would go for C. And then it says in the alveolus, so it's in the lungs, so lungs are kind of up here, muscles are down there, so we go for C there. And the blood in region Y, so it's still here in the lungs, rather than here in the muscles, so C or D, but we've got higher CO2, so higher CO2, so that's going to be our dotted line, which is D. Explain the importance of the effect of CO2 on the dissociation curve. So it does move it to the right, but why is that important? Why does it help in any way? Well, that enables, unloading of oxygen or release of oxygen. So hemoglobin will release oxygen or dissociate oxygen, or you could say dissociate, unload, are other words you could use. The steep gradient in A and C are common question. So this steep area here. In this steep area you don't need to move much on this bottom axis to get a big movement on the side axis. You don't need to move much of X to get a big movement of Y. You don't need to move much of partial pressure of oxygen to get a big change in the saturation of hemoglobin with oxygen. So that's essentially what you need to say. So rapid between A and C there. So a small change in the partial pressure of oxygen gives a big change in saturation of hemoglobin. So again, allows rapid uptake or rapid unloading. So rapid loading of oxygen. And if you had kind of more space, you'd say small change in partial pressure of O2 gives large change in hemoglobin saturation of oxygen. Then the process by which gases are exchanged, that's okay, just diffusion. The capillary regions X and Y represent the smallest divisions of 2 major blood vessels. So you just need to which way round is this? So we said that blood was coming in with low oxygen and getting oxygen and leaving there. So X is so coming with low oxygen into the lungs, so that would be the pulmonary artery going to the lungs. So going to the lungs with high oxygen and low oxygen and high CO2, yeah, that makes sense. So Y would be the pulmonary artery. Explanation, you've got low oxygen blood from the heart. So if you remember the circulation diagrams you drew originally, and so X must be the pulmonary vein. So now you've got high oxygen blood going to the heart. So high oxygen blood to the heart. And you could, if it was worth more marks, you'd probably give numbers for 9.4 kilopascals and so on. Low oxygen 2.8. You could give numbers there. On the graph, draw the curve for fetal hemoglobin, and it can't go higher than what we've got probably, so it'll be, does it say where to draw it? Draw a curve. So I always remember it as left for llama, lugworm, little baby or fetus. So we're going to draw it left, so it doesn't matter exactly where we put it across here. That's rubbish, but the essential point is it can't go higher than 100. It needs to go through the origin and it's to the left. So that'll do for our curve. Fetal hemoglobin, bit rubbish. So there'll be marks for the kind of S-shaped and a mark checking you've gone through 0 and not higher than 100. Explain the position you've chosen for your drawing, and we're going to relate this to a higher affinity of the fetal hemoglobin for oxygen, so it can take up oxygen from the mother. So higher affinity of fetal hemoglobin for oxygen, so can gain oxygen from mother's blood.